Hi everyone. Today we'll be talking about recursion and combinatorial a- algorithms. Most people are afraid of recursion, and this picture here is kind of weird as well. But I think that I can show you and I can explain it in a way that um, you just remember it and you'll think that it's not, too complicated. The thing is that if you explain recursion to a computer scientist, they might find it a bit weird, because for the most part you've been writing linear code where I can read this line, go to the next one, read this line. It's kind of a linear structure where you can just read the code as if it is like a book or something. You can follow the logic and so on. With recursion, things are a bit different. And for mathematicians, recursion is very very simple to understand, and I think to explain it as well. So one of the ways that I'll try to explain it is from the mathematician's point of view. Alright, so we'll be talking about combinatorics overview, where if some of you don't know or have not seen this lately, they might have forgotten it. Then we'll talk about recursion and combinatorial algorithms, where these two, number 2 and 3, are sort of combined. I wouldn't be doing like 2 is this and 3 is this, because recursion is used to solve algorithms in 3. Alright, so how many of you know what combinations are, with, without, repetition, stuff like that? Yes, no? Who is confident that they know it? Who is confident that who is not confident at all that they know it? Okay, so one who is sleeping, like at least 5 of you. Alright, so let's first start with combinatorics. This is a branch of math that studies finite or countable data structures. If you look at the one below, I'm sorry, is there? No, I didn't get this. So you can think of it as the science of counting. Okay, it's sort of a smart way of counting objects and other things in the smart, good way. Because if you have to count something to, I don't know, to 1,000 or something, one by one, it will take you a lot of time. So this branch is sort of concerned with ways of counting, like clever ways. So we'll revise the basic definitions of permutations, variations, and combinations. And I have to mention that in English, like if you do maths in English, these two are the same, or we use the same word, which is this one. So I know that in our schools, in our system, those are two different things, but just try to think that they're the same, and I'll show you why as well. Alright, so let's keep going. Okay, so let's start with permutations, and those are the easiest, I think. So imagine that you have n objects, and you can place them in n, let's say, boxes. Okay, the order here is important, or it matters. Okay, the number of permutations of an n set is n factorial. So this exclamation mark here, that's what it means. And below here I am defining this function it's n times n minus 1 times and so on times 2 times 1. And we have to add the following, which is 0 factorial is 1. Okay, do not ask why. It doesn't make sense, and it shouldn't. It's just by definition. Okay, so some mathematician says, well, if 3 points are not all on the same line, then you can make a triangle or something. So it's like an axiom or something that you should just believe that it's true. Okay, so let's do an example of that. So let's not think of this. So what are permutations? That's what we'll see now. So okay, so let's have, you know, some elements. Let's say 3. So 1, 2, and 3. And let's say that we want to place them in some boxes, which are, let's say, A, B, and C. Okay, so in how many ways can this be done? Okay, 6. So let's first do the formula, which is 3 times 2 times 1 equals 6. Okay, can we now see what all of them are? So this is, you know, a very, very quick way. We didn't have to write all of them, you know, to get the answer, which in this case it's easy, but let's say something for like 6 or 7 or even 10, it would be impossible to write all of them. So this is what, you know, combinatorics is. It's a clever way to calculate some things about orderings and stuff like that. So okay, so can you tell me what they are? What all of the permutations are? 1, 2, 3. 1, 3, 2. 2, 1, 3. 2, 3, 1. 3. I would do 3, 1, 2 first. Okay, and 3, 2, 1. Why did I do this one first? Because no, it doesn't. I mean no. I could have done a 3, 2, 1 here and 3, 1, 2 when you were listing them, but why did I correct you here? And I said, well, I would rather write 3, 1, 2. So they're ordered, you know, by I don't know how large the number is, but it doesn't really matter. You could have done it in any way. It was just enough to have, you know, all of these in the list. Okay, why do we say that the order matters in this case? Okay, it's not just the set of numbers, right? 1, 2, and 3. So if it was a set, like a mathematical set, 1, 2, and 3, then it wouldn't really matter how we write it, right? Because it will be the same set. So if I write this as 2, 1, 3, this is the same set of numbers, but in this case we say, well, the order matters, and we are just trying to get all possible 3-digit numbers with the digits 1, 2, and 3, which is fine, and we did it. Okay, so let's add another condition. So let's say that we can now repeat the numbers. Okay, this is a formula that we don't have on the slides, but how would you approach it? Let's try and do it again. Now you can repeat it. So how would you start?
It's 3.
Sorry?
The first one is 3. Then you have one. You mean the combination?
Yeah.
Okay, then 1, 1, 2.
Okay, 1, 1, 2. 1, 1, 3.
1, 2, 1.
1, 2, 1. 1, 2, 2. Yeah, but you know, it gets harder and more complicated and so on, and we don't have a formula for it, right? Which makes it even more complicated. So I would like to tell you of a method which is very, very simple, and you wouldn't have to remember any of these ever again. So these, this one, the one that I'm gonna tell you, and so on. So you just put some boxes. So let me do that on a new screen. You just put some boxes here, and so we want to place 3 elements. Let's start with the first case. We want to place 3 elements here, and we want them to not repeat. Okay, so how many options are for the first one? 3. For the second one, 2. For the third one, we have 1. Okay, when we multiply out these, we get 6. Okay, so how about if we have now with repetitions, how many do I have for the first one? 3. For the second? Okay, 3 and 3, and these are 27. Okay, now if I had to come up with a formula for n boxes and n numbers, what would that be? Let me just put those here. Actually here. Okay, so how would you do that? So this is box number 1. Sorry, I have to put it somewhere else. This is box number 1. This is box number 2, 3. This is box number n. Okay, so how many are there for the first place? Okay, n for the second, n, and so on. So what is the final number of n to the power of n? Okay, and this is like, you don't have to remember this. Okay, so when someone says permutations with repetitions, what was the formula? You don't have to remember this just because, you know, it's very, very clear. You can just do it with a simple example like this one. Okay, now let's move on to the next part, which is this one. Okay, how about if we have n objects, but we have k boxes where k is less than n? And I'm not going to show you the formula. Let's just try and do the same method, right? Because I can tell you, and it doesn't look nice, this one. But let's try and do the same thing with the boxes. Okay, so let's say that we have the elements 1, 2, 3. Let's start with that. This is a smaller case. So let's try and do that. So how many, let's say that we want to do permutations with 3 elements, and we want to take, I don't remember whether it was written this way, but it doesn't matter. So we have 3 elements and we have only 2 boxes. How would you do that? What are the numbers that we should get? Someone else? Okay, so we have 2 boxes and we have these 3 numbers. So how many 2-digit numbers can we make out of these 3 here? Yes, anyone? Without a repetition first. Okay, someone please say the first number. It is 1, 2. The next one is 1, 3. The next one is 2, 1. The next one is 2, 3. 3, 3, 1. 3, 2. Okay, we got 6 again. But what happens if I have, say, 1, 2, 3, and 4, and then we want to make up all 3-digit numbers out of these? Okay, so now if you have to list them all, it's not that easy, right? We have to come up with a better way, and this way is absolutely the same as the one that I've shown you a couple of minutes ago. So we just have 3 boxes. For the first one, how many tries we have? 4, 3, and then 2. Okay, so this makes 24. Okay, what happens now if I say, well, let's do it with repetitions? 4, 4, 4. So we can start with, if I do it here, this is 1, 1, 1, 2, 1, 3, and so on. We can have 2, 2, we can have 3, 3, and so on. So this thing here is 4 to the power 3, which I don't know what that is. 16 times 4, is that 64? Yeah, okay, I think. Calculations are always hard. Okay, so now can we, with this knowledge here, that we have, can we do the same thing where can we come up with the formulas for each one of these so that we don't have to remember it ever again. So let's say that we have boxes. This is the final one, and here we have box number 1, number 2, number 3. What's the final one? Let's say that we have n elements and k boxes. This one would be k, the final one, right? So how many do I have for the first one? N. For the second one, n minus 1, n minus 2. And now a trick question. What's that thing? No. Okay. N minus k plus 1, right? Because here we start with n minus 0. Okay, and this is 0, 1, 2, and this is the kth element. If I ended at n minus k, this would now be n minus k. I'm sorry, this would be k plus 1 now elements. So yeah, it's like if I start from 0 and I want to count to, let's say, 1 and 2. Here we have 3 elements and not 2, which is the final number in the sequence. Okay, so we came up with that. So this is like, let me just type it out. And this is n times n minus 1, n minus 1 times, and so on, up to n minus k plus 1. Or the number of these is k. Okay, and there is a way to write this. I'm not going to type it with the text, but it's called nk falling. Okay, with an underscore, which means let's start with n, multiply numbers down until we get k elements in total. Okay, so times n minus 1 and so on until we get to k. That's just it's similar to the exclamation mark for the factorial. So it's similar. It's just a way of writing it down. Okay, and the easier one, which was with repetitions. So now let's say that we have again k boxes. I'm sorry, this is 1, this is 2, 3, 4, up to k. And now let's say that we do it with repetitions. So how is that done? Okay, n to the power of k is the answer, because here we have n, and so on. And this is k times. So how do you feel about that? It's even like very, very easy to remember. One of them is n to the k, the other one is nk falling. Like, it's very, very similar in the way of writing it down. So have I helped you? Are you ever gonna like not remember these? It's very, very easy to come up with the formulas just using a couple of boxes, and that solves it all. And this is the formula that we have here, and I haven't given the one for repetitions. So the idea, when we get to the algorithms, is to generate all possible combinations, because we can't do this by hand for large numbers, but the computer can, and this is what we will try to do. First, we have to talk a little bit about combinations as well, and did I change this? Do I have 2 slides which are the same? I do, apparently. Okay, so we have combinations which are harder in terms of, like, I cannot explain them to you in this way, and I wouldn't be able to tell whether that's easier. Okay, but the idea is very, very similar. We have n objects, and then we have to combine them, like k of them, but the order this time doesn't matter. So what we have to do is now have a set of some elements where the order, you know, in sets like mathematical sets, the order really doesn't matter. It's like in how many ways can we make a group of 3 people to go somewhere, right? Where the order, what's important is the group and not the order. So let's try and do the same thing. So let's try and do 1, 2, 3, 4, and let's make all 2 sets, which means sets of 2 elements out of these numbers. So can someone help me out? We don't care about the order, so you can do it. 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, 3, 4. And that's all of them, right? Yeah, it's that. It's quite simple. All right, and you know, listing these is also what we want to do with some algorithms that we'll be doing a bit later. But what's the number of combinations? It's slightly harder. It's basically this formula. Or another way that you can calculate it is P n k over k factorial, or this was nk falling divided by k factorial. But that really, you know, just it's just a calculation that we're not going to really care about in this specific lecture. All right, so let's talk a little bit about recursion. Okay, and this is when what I said at the beginning. Some people think that it's hard because it's not the usual way you would think a program works. But in fact, this is possible to be done, you know, in any programming language. It sounds a bit weird at first. Maybe you have some struggling with it, but in fact, I think it's quite, you know, easy once you get used to it. Okay, so in one sentence, a recursion is when a method calls itself. Okay, so we have a function which is, you know, hello, and inside, why do I write it this way? Hello, and inside we have the same method hello, which is called. Okay, which is, you know, kind of weird. So what's going to happen if I run this code? I'm sure that some of you know the answer. Okay, so we are going to get some error, and the problem is that this is, you know, infinite calling of hello, because we are going to have hello here, which I'm just going to say h. Okay, so h calls h, which calls itself and calls itself again and again and again without ending, right? So this thing is going to execute for as long as we can, or in this case, since there is a memory limit, then until we run out of memory, in which case what error do we get? What error do we get, or what exception in C#? It's written here. Okay, so Stack Overflow. And it's very interesting when you're actually looking for this error in Stack Overflow. You know, you can get, I don't know, confused, because how would you how would you look for that specific thing, you know? Okay, it's very powerful, you know, for combinatorial searching, sorting, and so on. Once you get used once you get used to it, you know, you can implement various algorithms with ease. Okay, so it can be direct when a method calls itself, or indirect where you have some sort of chain. So let's say that A calls a method B, which calls a method C, which calls A. So this is going to do the same type of chain that we were talking about, which doesn't have an end, and you would normally get an exception. Okay, to avoid getting this, we should have some exit, right? Or this is called bottom. Saying, okay, so we've reached this this state of our method calling, and we say, okay, so stop, and now you should go back, which we'll see as well. Okay, and now comes the sort of mathematical view on the topic. So recursion is normally used when you have a problem where the solution can be divided into steps, and each step is determined by the previous step. Okay, so the first and probably easiest example that I can give is with n factorial. Okay, so this can be, although it's not necessary, I mean, I'm sure that all of you have solved this with a simple loop, but to explain it better, I would just like to use this one. So what if I tell you that I can define this, and let's say that this is factorial of n. If I tell you that we can do factorial of n equals n times factorial of n minus 1. Okay, is that going to be true? What do you think? So when I have to substitute here, this whole thing, it will be n times n minus 1 times factorial of n minus 2, and so on. Okay, until we get to 1, factorial of 1, which we know that it's 1. Okay, but the idea here is that this is some kind of recursive definition of the problem that we need to solve. Okay, so in this case, factorial of n is dependent on the previous value, which is the same thing of n minus 1. Okay, can you tell me of another example where a function is defined recursively using the previous element or elements that you've seen and is very popular? Fibonacci. Okay, so Fibonacci, I'll just call it f. F of n is defined to be, what is f of n? I'm sure that you've heard of it and you've written it with code as well in the first. Fibonacci, f of minus 1 plus f of n minus 2. Okay, and so how does it start? It starts with 0, 1, and then every next element is when we add the two elements before it. So this is going to be 1, 1 and 1 is going to be 2, 1 and 2 is going to be 3, 2 and 3 is going to be 5, and so on. Okay, so this is a very good example of when to use recursion, because this whole thing is defined recursively, in the meaning that is defined by the previous steps, or we can't just say what f of 35 is. Can you do that? Can anyone tell me like straight away what is that? Okay, so you would have to go from 0, 1, 2 and then count to 35 in order to give me the value. Interestingly enough, there is a formula for f of n which is not recursive, but it's like it's relatively big, and you would be amazed that it gives you the answer, but we are not going to do that now. So there is a way to give like some function of n, which is just going to give you straight away the answer. So something like square roots and so on, but we're not going to do that now. We are just going to assume that we can solve this with recursion, because it's defined with the previous steps. And you know, there are plenty more cases in which you can use recursion. You just have to think, well, does it depend on some information that I do not already have? Does it depend on the previous case which I haven't solved, right? So here we have f of n minus 1, which we don't know what it is, but we can find it by using f of, you know, n minus 2 plus f of n minus 3. Okay, so this is something that I still don't know, and I have to go in, you know, deeper until I find some value that it's going to help me. Okay, so this is the idea. If you have something that depends on some information that you do not have and can be calculated by repeatedly going deeper, then that's a clear sign that you should be using recursion at some point. Okay, i.e. with respect to a previous step or steps. It depends on the case. Okay, before we go into the demos, let's have a short break. Are there any questions, by the way? Anything that I did not explain properly, or... Okay, if you have some, you ask them, I guess. Alright, so the rest of the lecture will be just some examples with recursion. So the first one will be Factorial. After that, there was one more here. We'll do the Fibonacci as well. Then we have some 8-bit numbers. I'll tell you what those are. We'll go on to the combinatorial ones. It turns out that combinations are a little bit easier to implement. After that we have permutations, and then we'll do some searching in a labyrinth. We'll see how that is done, and all of these, you know, the advantage of using this method is that it's in terms of code, it's very, very small. You know, it just a couple of lines can solve you a complicated problem. So let's get into Visual Studio. Let's create a new project, which is gonna be recursion. Actually, let me get here blank solution. Okay, this will be recursion, and I'll click OK. The first one we'll do is Factorial. So let's let me add it here. It's gonna be console application. So one is gonna be what was the first one? Factorial. Alright, I hope that you can see fine. So the first one, I'll just leave that. So let's rename a couple of things here. Factorial. Yes, I do. Let's do it. So let's first get a number from the console. So it's going to be int num equals int.parse console.readline. And then we would like to just print the result. So it's going to be fact of factorial, or just, you know, calc factorial of num. Okay, and we have to write a method that does that. So let's do it. So private static void calc factorial, and it's gonna get the number of what we want to solve. Okay, so there are two things that we need to do. The first one is actually solve the problem, and the other one is to create some sort of a bottom or some sort of an exit of our recursion. And I normally find the exit to be easier, so I normally start with it. So can you tell me when should we stop executing?
If a number is 1.
Okay, so if num equals to 1, then we just want to do something like exit, and I'll tell you what that is. So the idea is, okay, so we start with an n. Okay, we do some calculation which requires a previous step, so something like n minus 1, n minus 2, and always the first thing that we should ask is when does it stop. Okay, and in this case it stops either when num is 1 or 0, and then we have a fixed value for what we want to give as an answer, right? So what is the answer if num is 1? So what is 1 factorial? It's just 1. Okay, so this is what we will be writing. It's return 1. And in this case, since I am giving numbers, and here I've said that it's void, actually I should change that to int. Okay, so this is when we, when we stop executing this method. But what is it that we actually want to do? Okay, so at each step, let's say that someone gives me a number 5, and I want to calculate that. So what I want to say is, well, this is 5 times 4 factorial. Okay, so we notice that this and this are the same, right? So I should be using the same function here, and this is exactly what we have. So this is gonna be return. What should I be doing? Calc factorial of num minus 1, but I'm also missing something here. So if you remember, it was 5 factorial equals 5 times 4 factorial. So here I am missing something, and what is that I'm missing? So I have this part, and I should just add this one. So it's like num times this. Okay, so the point is you have to define your step. Okay, so how should you call? So what should you do at each step? If you don't know what you're doing with the problem in general as a whole, how would you solve it step by step? And in this case, I told you, you always have to do this equals n times n minus 1 factorial, and this is your step. So okay, I don't know how to calculate all of that, right? I don't know what 5 factorial is, I don't know what 4 is, 3 is, and so on, but I know a way that I can get lower and lower, and this is by this way. Okay, so let's talk a little bit what this code is gonna do. So first I can just run it, of course, and it's gonna work, I think, I hope. Otherwise it would be kind of sad. But yeah, let me just run it. Let's just put something that we know the value of, something like 3. Okay, so 3 gives me the answer 6. Let's do something else. Maybe 5, 120. So that is 1 times 2 times 3 times 4 times 5. Okay, that is 6 times 5 is 30 times 4 is 120. So it looks like it's working. Okay, so let's see how this thing works. I mean, like step by step. So let's add a breakpoint here, and let's debug and let's see what's happening. Alright, so let me input a 5, and hopefully I will be getting this thing, which is the call stack, which we should be looking at in detail. But first I want to show something. Okay, right, so we see here, actually we don't see, okay, we see this thing here. I have called this method with the number 5 in this case. Okay, so let's see. Okay, so we check it's not A1, and then we go to this line, and that says, well, call it with 4. Okay, so what's happening here? I call it with a 4. Okay, and I'm gonna keep doing that until I reach some bottom or some exit function. So let's do that. Okay, so now it's 3. Now it's 2, now it's 1. Okay, so we are at the 1, then we say return. Okay, and you will see that it's gonna go back some steps. Okay, so now we have how much is f of 1, then we go back, we can now calculate what is f of 2. We do that, we can do now f of 3, f of 4, f of 5, and after that we just print the result. Okay, so this is a call stack. Do you remember the keyword stack from a couple of lectures ago? So what this thing does is, let's say that we have a stack or a bucket. I'll write it a little bit bigger. And what's happening here? Let me just put in a couple of levels so that we can see what's going on. Alright, so what's happening the first time when we call it, there is a function that goes into the call stack. So this is, oh my god, I didn't just do that. 1, 2, 3, 4, 5. Okay, so we have a function that goes inside, okay, and it's gonna be f of 5. It's the first one that we called, right? Okay, and it says, well, give me f of 5. The function tells me, well, I don't know what that is, but I can, but I know that it's number times the previous step, which is f of 4. Okay, so now in the call stack we have f of 4, which comes here. Okay, and so on. F4, we ask it, well, what is f of 4? Well, I don't know, but I know that it's 4 times f of 3. Okay, so we do f of 3. The same way we do f of 2, f of 1, and so on. Okay, if we don't have the bottom or the exit, we are just going to keep doing that indefinitely. Okay, until we run out of memory. But in this case, we go to f of 1. Okay, it says, aha, this is 1, and I know that it's 1 because of this line of code here. Okay, so now that we know that this is 1, I can just take this out. So taking this out, I know, okay, so f of 2, I know that it's 2 times f of 1, but I already know what f of 1 is. Okay, so this is gonna be now 2. Okay, the same goes for f of 3. Okay, it's 3 times f of 2. I already know what that is, so that is 3. Sorry, this is 3 times 2, which is 6. Okay, in the meantime, every time when I execute or when I go back the call stack, or when I know a value of my f, I just remove it from the stack. So I know that I should keep going down the call stack until it's empty and all of the code has been executed. Okay, so f of 3 is 6, then we get 6 times 4 is 24. This thing goes out of the stack. And finally we have f of 5, which is 5 times f of 4, which we already know. This is going to be 120. Okay, and we saw that with the stack here as well. So it's like, let me run that again. 5. Okay, so call stack. First we have f of 5, f of 4. Then we add f of 3. It's like, adding to the pile, of functions to be executed, and are just waiting for something. They're waiting for some kind of result. Okay, once we get to the 1, now we have the answer, and the stack is just gonna pop the elements in the order that so starting from the last one that came in as a stack. Okay, I think it would be good to just show you, if we don't have this, Control KC, what's gonna happen? I should be getting something. Stack Overflow, sorry? I haven't entered a value. Thank you. So I'll just write a 5, and we get the error, which is Stack Overflow. Which means that, so let's see that in code as well. So let me go here at 5. Enter 5 again. It doesn't matter what the number is. Okay, let's try and do the same thing. Okay, so we go 5, 4, 3, 2, 1, then 0, then -1, and we just keep piling up functions one after the other, and this process is gonna stop when we run out of memory. Otherwise, it will go, indefinitely. So yeah, -2, -3. There is no step at which we say, well, here you have to stop. This is an information that we know. Okay. So that's the general idea. So this is calling recursive function or a method. This is the bottom of recursion, and this is the recursion call or recursive step. Okay, and every recursion should have these two. So we have to have a bottom, and we have to have some step which is gonna solve our problem, which is done via calling the same method once again. Are there any questions? How does that feel and sound? Sounds okay. Awesome. Sounds awesome. Okay. Right. So let's do the next one, which is Fibonacci, which is going to be very, very similar to this one, and I'll actually ask someone to help me, because it's very, very similar. So this is going to be 2 dots Fibonacci. Okay, and let's do it here. Alright, so let's do the same thing. Let's give a final value of what we want to calculate. So I guess I'll just copy that. Console right line, calculate Fibonacci. Okay, and let's write the function. So this is going to be private static, I think int calc Fibonacci. Okay, who wants to help me with the recursion here? How would you calculate it? So let's first identify our step. So that's gonna be Fibonacci of n. What is that equal to? Okay, so f or fib of n minus 1 plus fib of n minus 2. Okay, so this is, we have n. To calculate it, we need to go to the previous two numbers in the sequence. Okay, so here clearly I should put num, and clear I should have int num. Okay, so let's first do the bottom. So how is that gonna sorry, how is that gonna look like? Okay, so if num equals 0, then what number should we have? Sorry, what should we return? Return 0. The first one is, okay, so there are two definitions. One of it is, 0, 1, starts this way. The other one is 1, 1. It doesn't matter which one we use. We can do it with 1, that's fine. Okay, something else? Probably? Or no? Okay, so how do we do the step? How do we do the recursive call? Return calc Fibonacci of num minus 1 plus calc Fibonacci of num minus 2. Okay, let's run it. Let's input something like 5, and this is the previous code. So I'll just do properties, current selection, go to this one. Let's put, I don't know, 7. Okay, and we have a problem. So when you write recursion, you will get this quite often. Okay, and you have to think about what's wrong. Now it should be working, but it doesn't. So what is the problem here?
The num equals to 0 should be as well as to 1.
Okay, so as defined, let's try to calculate, f of 3 this way. Well, this thing says, well, this is f of 2 plus f of 1. Okay, I know what that is, right? Sorry, no, I don't know what that is. So to do that, we need to calculate f of 2. So f of 2 is f of 1 plus f of 0. Okay, and I know what that is. This is 1. This is 1. But I don't know what f of 1 is. Okay, so I go down, and this f of 1 equals f of 0, which I know what that is, but I don't know what f of minus 1 is, right? Because we just decrement the num value. Okay, and now it's gonna take this. Well, I don't know what that is. It's gonna do f of minus 1 equals f of minus 2 plus f of minus 3. And this is why I mentioned that the Fibonacci sequence is defined with its first two values. So it's either 0, 1 or 1, 1. And after that we are free to go and calculate the rest. So this is going to be 1, 2, 3, 5. In the other case it's going to be 2, 3, 5, 8, etc. So we can have multiple exit criteria. So this is if num equals 1, then we also wanna return 1. And now if you put something like, I calculated up to 8, I think. So 5 is 8. The next one should be 5 plus 8, which is 13. So let's put 6. We get 13, and so on, which works. Okay, there is a note that I have to make here. This method, so let's go back to this one. How many steps is this gonna take, do you think? So is this slower than writing it with a for loop or a while loop, or is it quicker? How do you think? So a for loop would look something like result equals 1, then we have a for loop, and then we say result times equals I or something. Okay, so is this going to be slower or quicker? What do you think? It will be slower. Why?
Because first it checks every time for the number if it's one.
So it checks every time if it's one or not. Okay, but let's talk in complexity. Okay, because this is just one step that we can neglect. Okay, it's not important. How many steps is this gonna take? Or what is O of this recursive call? N, right? We just call it N times. How about here? So they're pretty much the same, right? Also, this line of code can be substituted in the for loop by two more. So in the for loop, we have one check here, whether we've reached our number, which is n, and also we are going to have to do the calculation, which is a result times equals, right? Which is again two steps which are repeated like n times. So it's pretty much the same. How about here? What do you think? Is it going to be slower with, like, if we do it with a for loop, or is it going to be quicker? This is going to be slower because I call two methods for each one. Okay, so let's have a look at that. So in the last problem we had like call f of n, then call f of n minus 1, then call f of n minus 2, and so on up to 1. Okay, so and these are like n steps. How about here? So here we have Fibonacci of, let's say, 5, okay, which needs Fibonacci of 4 and Fibonacci of 3. Okay, this one needs Fibonacci of 3 and Fibonacci of 2. Okay, but what's the problem here? Okay, so once I've calculated this value, and I finally get to f of 4, which is some number, I would still have to go back and calculate f of 3 once again. Okay, which is a problem since we are doing most of the operations twice. Okay, so let's keep doing that. So this is f of 2, f of 1, and this is f of 1 plus f of 0, right? So you see that those are a lot more steps that we have to do, and in fact this is really very slow. I think here the complexity is 2 to the power n, but I'm not really sure. You can very easily check this, because each of these divides into 2, and I have to do this twice. I think this is 2 to the n. I'm not sure, but it's definitely something bigger than a for loop. A for loop will take n steps, whereas this one is a lot slower, especially if you have to calculate like 10,000 or 20,000 elements. This one is going to be very slow. Okay, are there any questions here? No? Let's go on to the next one. So you see how even though we talk about recursion, which is a bit more complicated, a bit weird, it's still very easy to read and write these methods. So what we need to do is see what the bottom is, and after that just do the step which calculates our problem. Alright, so let's do the new one, which is new project. It's gonna be 8-bit numbers. Okay, so this problem is we have we basically need to calculate, or just give or list all of the numbers which can be written with 0 and 1 only, and they have 8 digits. So it's like 0 0. Let me just type that because that's gonna take a while. So 0 0 0 0 0 0 0 0. And we have 0 0 0 0 0 0 1 0 0 0 0, and so on. The next one will be this one, and so on. Okay, so all of these. There is an easy method to do that. So can anyone tell me of an easy way without doing it with a recursion for this specific method? How would you do that if I give it to you now when you don't know anything about recursion? So the other two were kind of simple, right? So this one and this one, a simple for loop would do the calculation for us. But this one is slightly trickier. How would you approach it? Okay, I'm gonna pause until I get some good answer for this one. Okay, so the answer is that we can convert these numbers. So 0 0 0 0 0 0 1. This is gonna be 1 in the decimal system. The next one will be 1 0, which is gonna be 2. The next one will be 1 1, which is going to be 3, and so on. The last one will be a couple of ones, so 1 1 1 1 1 1 1 1, and this is going to correspond to 2 to the power 8 minus 1. Okay, so we can have a for loop which starts from either from 0 or 1, it doesn't matter, up to this number, and then we can convert each one into a bit system, base 2, and we can print all of them. Okay, but that sounds like a lot of work, and with recursion it's a lot simpler. And then we'll see later on in the next two demos that if you want to change things up a bit, where here instead of zeros and ones, maybe we want to have something else like 1 2 or just some letters or something. This is not a good way of doing that. Okay, so let's change this to 8-bit numbers. Okay, and here okay, so let's have a number int num equals in.parse console.readline. Sorry. And then we would like to have also an array. So I can easily say, well, num is 8 in this case, where we have just 8 boxes. But let's do it for any number. Let's just generate all 2 digit ones, so 3 4 5, and we'll get to the 8 eventually. Okay, so let's have an array where we would like to store these values. New int num, and then we want to have a recursive call which is going to be generate 0 or 1. And inside here we would have to give both the num, so at which step or what we are giving, is it a 0 that we're giving or 1, and we have to give also a reference to the array which we are using. So in this case, let's start with 0 and array. I'll explain you what that is in a second. Okay, so generate private static void generate 0 or 1, and we'll have int index and int array. Okay, so what's the idea behind the recursion here? So how do we generate a number like this? And when I ask this, think about what we have to do at each step. Okay, so let's have the array here. Let's do it with something like 4 elements. Okay, so the first step that I'm doing here is adding 0 to here, to this place. Okay, so by knowing where we are at right now, which is position 0, after that, what we want to do is, what should I do in the next step, or how should I solve my next step? So what should I be putting here? Okay, so we don't know anything about these, and we definitely don't have a number that we can print out. So let's say that we are starting here, and I have to decide what thing should I put inside the next cell. Okay, so it's either 0 or 1, right? So this can be first, it will be 0. I'll go to the next one, it will be, let me write it in red. So this one will be 0, the next one will be 0, the next one will be 0 also. And at this point we have something to print, right? We will have 0, 0, 0, 0, 0. Okay, then we have to, delete this, go back. Okay, and say, well, okay, so here I have the 0, but I have two cases, right? The first one where here I have a 0, that is fine. I already have this, but I also have another case where I can put here a 1. Okay, and then I'm gonna print 0, 0, 0, 1. Okay, and so on. So I can go back now. Okay, so I have 0 here. I don't have anything else to add, so I have to go back once again. Okay, so here now I have 2 zeros and 2 empty ones. I've already put a 0 here, and I've done everything that I can with it. So here instead I'll just put a 1. Okay, and do the same thing. So at each step I can put either a 0 in the next step or 1, right? And I don't care about anything else. I don't care about what's before that, or what's 3 steps from that. We just care about what's the next step. So the next step is either 0 or 1. Is that clear? Yes? No? Do you want me to explain that once again? Okay, so let's say that we have the array here, and here we filled in some values that we don't really care about. We are at here, this place. Okay, so how do I fill the next step? Okay, I have to decide whether to put 0 or 1, right? I can put both of them in order. I can do first the 0 and then the 1, and this is what I do. So I increase the index. Okay, and then here I can either put 0 or 1. Okay, and this is all that I care about. This is the step that I care about. There is nothing else in my mind. I don't care what's here. I don't care what's here. So I just need to do the next step. Okay, if we do it this way, so let's start. Let's say that we start with our array from index 0. What's the bottom first? Bottom of recursion. Okay, we have all cells to have some value, right? So how can we check that? How can we check if we know filled it in enough times? The array is empty, yeah, but we fill it in with values, so it has to be filled in, not empty. Array dot length -1. Okay, similar, but so how do we check if the last cell is what we've filled in with some value? how do we check that? Well, here we have the index, which keeps track which cell are we currently in. So if you remember, I said we start with cell number 0, then we increase the index. This is going to be 1, 2. When is going to be the last step? When index equals to array.length. Okay, is that clear? This is going to be the last step. So we fill in the whole array, and when do we know that it's filled? Okay, so when we've incremented from 0, 1, 2, and so on, up until, in this case, well, it's going to be 7. In which case, we are going to make another call. We are going to call the 8, and we're going to say, well, we don't have an 8, so, you know, just stop. Okay, so this is going to be just return. And at this point, we have an answer that we have to print out. Right, so this is going to be console.writeLine, string.join, if you remember this beautiful method. Here we have a pause, and I would like to give array, which is going to print it for us. Okay, so this is the bottom, that's fine. And then what is it that we want to do after that? We need to solve the problem. So I said, you know, at the next place, either place a 0 or a 1. Okay, so it's one of the two. So we have generate 0 or 1 in the next place, which is going to be index plus 1, and array. Okay, and we are going to have the same thing, but generate 0 or 1, index plus 1, array. Why do I write it twice? Because we will need to have two different cases for the 0 and the 1. So in the first one, where I just changed the step, so imagine that we've just changed the step. So this is like some 0, here are some x's. I go in here, okay, and I have to decide, should I put 0 in here or a 1? Okay, so we have the two cases, and this is going to be array of index equals 0 and array of index equals 1. So it's one of the two. Oops. This way. Okay, is that sort of clear? So this is like case 1 for a 0 and case 2 for a 1. Okay, and then we'll so let me just show you that it probably works. So if you put in something like, come on, I'm sure that you can do it. Okay, so if you put something like 4, and I think that's all of them, right? It looks like it, definitely. Alright, so let's kind of trace what's going on here. So let me go to here, probably press F5, input the same number 4, and let's see what's going on. And to see it, I'll actually want to take a look at the array to see what's going on. Okay, so the array, let's assume that it's empty. Okay, so first we'll have to look at both the call stack. Does it show what I wanted? Okay, so but I need to make it maybe a little bit bigger. Index. Okay, yeah, we'll just need to see that. Can you see from back there? I hope you can. This is a 0, and here we'll take a look at the array. Okay, so the first thing that we do is we put a 0 in, okay, and then we call this method. Okay, So we are now at index 1. Okay. We put a 0, then we call it once again with the next index, and we see that here the index is now 2. Okay, index 0, value 0. Okay, so now the index is 3, and we place a 0 once again. We call it once again, where now we have the index is 4, which is now bigger than the length, right? Or it's in fact the same as the length. So now we print it, okay, and then we get back a return. Let's see here, we have the zeros. Okay, so what's that gonna do? We go back a step. So if you notice here in the call stack, we are getting back one step, and then we'll keep going here. Array of index is 1. Okay, and we print it. Once again, we have 0001. Okay, is that clear? So we go recursively 000. Then we say, well, we are now done. We print this. Then we go back 000. This one can be also a 1. We print it and we go back. Okay. Is that sort of clear, or does anyone have any questions or feeling confused or something? Okay. No. Right. So this is what we do. Can you tell me now, what should I change to get all digits? Actually, we didn't try it with 8, so let's do that. Control F5. Let's say 8, and I think we get all of them. We don't have to check. These are 255 numbers as we discussed. Actually, with the 000, it's 256. Okay. So now, can you tell me what should I change if I want to generate, instead of all 0, 1 numbers, say with 4 digits? What should I do if I want to do, say, with 1 and 2? Array of index equals, and the second case is 2. Alright, so let's have a look. Let's put 4. Now we get the same thing, but instead of zeros and ones we have a 2. So can you come up with a clever or easy way to do this without recursion? There may be one, right? But it's a lot more complicated than the one that we discussed with a for loop between 0 and 255. And what's gonna happen, or what should I change if I want to do something like, instead of 0 and 1, if I want to have A's and B's? Okay, or what's gonna happen if I want to have something like apple and orange? Okay, so all possible words or sentences which have, these two instead of 0 and 1. Right, this is going to be really simple. I just need to change, instead of this being an int, it should be an array of strings, and then I should do the same thing, but here I should say, well, this thing is apple and the other one is orange. So that is now very, very easy, and you can do all kinds of things that you want to here. Say with 5 and 6, it's going to be the same thing, the same code. You don't even need to do anything else. All right. Can anyone tell me of a better way to do this? So let's get back to the 0 and 1 case. So can anyone tell me a better way to do this thing? Because this is kind of a repetition of code. Is there any way that I can combine it into a single code? Like here we clearly have this line is the same, this line is the same, and here we have a change of value from 0 to 1. So is there any way that I can combine these two cases into a single case? or a single like structure of code. So that, because what's going to happen if here I want to have a third case or a fourth case and so on, I would have to, you know, copy paste this all over. Anyone? Okay, so let me do that. Case 3 for a 2. Array of index equals 2. Generate, I'll just copy this line. For loop, thank you. So I can do that as well. And if I put in here 4, once again, we'll have not only with 0 and 1, but we'll have 0, 1, and 2 as the 3 cases. Actually, let me put in something a little bit smaller so that we can see the whole thing. Alright, so it starts the same way, but we also have 0, 0, 0 with the 1, and then we have a 2, and it's going to do all of the possible, you know, combinations of these numbers here with 3 digits, and then we can combine all of this into a Control K C into a single for loop, which can start from 0 up to, let's say, 2. And in here, array of index equals 0, and generate, sorry, this is I, yeah. And we have generate 0, 1 index plus 1 array, because, you know, this is repetitive. Okay, we don't need to do that. And now it's very, very easy to modify this. I can start from 1 up to 5, and we are gonna get something bigger, I think. So all 2-digit numbers with 1s and 2s and 3s and 4s. Okay, does that sound similar to something that we've done at the beginning of the lecture? Or yeah, right? Or no? What is that similar to? Permutations, I think, because here 1 and 2 and 2 and 1 are clearly different, so they're in the list. So permutations of 4 elements, and we have 2 boxes. All right, so let's but these are, you know, with repetitions, right? If you want to make it without, it will be something a bit more complicated. All right, so now we are gonna make the transfer between random problems to ones that are in combinatorics, and we'll start with the easiest one, which is combinations. So new project, this thing here is number 4, that's gonna be combinations. And from now on, it's going to be very, very similar to the structure that we have here, right? A single for loop, and we have to decide where to start from. So this is like the start and the end. We have to decide where to start from, and how are we going to, you know, generate everything. But it's going to be relatively simple. So I'll do that very, very quickly, and then we'll have a short break before our last 2 demos. So combinations, and here it's pretty much the same thing, with one key difference, that we would like to have a start and an end. So inside this thing here, we always say, well, always generate from 1 to 5. Okay, and in each step, if I run this once again, at each step we can get this one twice, or, you know, 3 times if there were more places and so on. And here we would like to actually keep track. Well, so if I have 1, then I want the next number not to start from 1, or this, you know, starting index here, not from 1, but from the next number in the line. Okay, so in this case If I have a 1, I want to say, well, the next for loop shouldn't start with a 1 but with a 2 with the next number. Then I want to say, well, it should start with a 3 instead of 2, and so on. So this will be done relatively easily. So console.write, we should just have a start and an end. And so I'll just copy that. Actually, no, let's do int start equals int.parse console.readline. And now I can copy this. So we'll have a start, an end, and we'll also need some number, which is going to give us how many places we have, which in the last case was 8 or 4 that we've used most often, so something like 0, 0, 0, 0. This is 4 places that we have to fill in. So we have start, we have end, and we have, I don't know, places. Or places, yeah, I think that's fine. Okay, then we can create our array. So it's going to be int array equals new int of places. Okay, so now this is going to be very, very similar to the previous one. The only thing that we need to add to this method is where the start is and where the end is. So let's do that. So combinations, we'll do calc combinations. So we'll have start, end. The starting index is once again 0, and we have to give in the array as well. Okay, so static, is that going to be void? Calc combinations. Okay, so we'll have int start, int end, 0, and then array. Oops, this is int index, and this is going to be int array. Okay, so what's going to be the bottom? I said it's very, very similar. So when have we filled in the array with combinations? And before, I think I need to revise what those are. So we have, let's say that we have 3 boxes. Actually, this is not gonna work. Let's say that we have students. Okay, we have 8 students, and we have to select 3 of them to send somewhere, like on holiday or something, I don't know. So what's important here is not the order, but it's like the group itself. So in this case, 1, 2, 3, and I don't know, 3, 2, 1 would be the same. So we don't really want to care about that too much. Okay, so at each step is very, very similar to what we did with the previous thing, but we need to have a start and an end. So here I have given them just as values, which are 1 and 5. But I want to have actually where it starts from and where it ends to. So in this case, I said that it's the same thing. So we want to have an array that we fill in with values. So when do we print, or when do we finish with the recursion? When do we say, stop? We are done here. Is anyone listening at all? If the index, thank you, if index equals to array.length, then we want to print it. So console write line string.join separator, and then we want to have array, and then return. So go back. All right, and the problem that we have to solve is again the same. So for this time is gonna begin from the start until the finish values that we have given. It's end, yeah. We want to make that equal to, and then the same thing that we have to do. So array of index equals I, and calc combinations. And now what is it that we need to give as values? Sorry? Start plus 1, right? We want to start from the next number in the line. So start plus 1, then we want to have end, then we want to have index plus 1, because we want to move on to the next element in the array, and then we want to have we want to give also the array. So it's pretty much the same as here, okay, but we just changed these values to be start and end. So this is a good time to make a note. Once you want, so if you want some values to be traveling along and keep track of inside the recursive calls, they should be a part of your method. Okay, so if I want to keep track of the start and the end and want to do something with them, then I just cannot do it with this method right now. Right, there is no way to keep track of the information. Maybe you can if you make them, you know, static variables or something, but that's never a good idea. But normally, if you need to transfer some information inside the recursive calls, you should always put them as values here. And if you remember, this is what we started with. Factorial, we only needed to keep track of one value, which is num, for the previous step. Here we want to keep track of, again, the previous step, which is num. In this case, we want to keep track of two things. The first one is the index that we've reached, and the other one is the array that we need to fill in with values here. And we have to do this, the start, the end, and the other two. And this is why our methods now, like our recursions, are now having more parameters, because there is more to keep track of. So let's say that we have, so what was the example that we did? We did 1, 2, 3, and 4 as values, and we wanted to generate all with two places, right? So 1, 2, 1, 3, 1, 4, 2, 3, 2, 4, and 3, 4. Okay, please note that we always, you know, increment the start, and then the, sorry, just the start. So here this 2, then goes to 3, to 4, and so on. This one goes to 2, then goes to 3, and we're not going to get any, you know, repetitions this way. So let's put so starts, let's say, with 1, end is 4, and places are 2. Okay, but I do have repetitions that I can get rid of as well. But we'll do that after the break. So yeah, how would you get rid of the repetitions in this case? So if you noticed, we had places 2, we had 2, 2, and then 3, 3 here. How would you get rid of the repetitions? And that's a very simple question. Like, sorry? We also have 2, 3, 2, 3, and 3, 2. Huh. Okay. Okay, I guess that needs some fixing, or I didn't write something properly from my code. In any case, I have to look at it. So yeah, let's have a short break and then we'll keep going. Okay, so the problem was that instead of start plus 1, we had to use I plus 1, which is, you know, the next value, or the next step that we from the one that we're currently using. So this is the value I that we give to the array at the specific index, and we want to always, start at the next one, which is now going to generate the correct result. So places are 2, and there we go. All right. I do not know what that is. Okay. So now let's do the new one, which is number 5, permutations, and that's going to be very, very similar to the one that we just wrote, but with a slight difference. So when we do permutations, notice that, let's say we do 1, 2, and 3. 1, 3, 2 is also going to be in here, right? So there is no way to do this kind of trick where we always go from the next one, right? That's not going to work. So we need to do something a bit more clever, I would say. But let's first start with this demo that we wrote a while ago. So if in here, sorry, we just here I've left it with 1 and 4. Okay, so 1 up to 4. Now if I give 4 places, let's do something smaller. I don't want to read that. So up to 3. If in here I put 3 places, then here we pretty much generate all of the permutations, but with repetitions. So you should think that we should change something kind of small in this code, and that should work. Okay, so can anyone give a suggestion or something? So imagine that you have to do it now, and what would you do? If the index of the first one equals to the second one, then just don't what? Don't call the function. Okay, but here, we don't do pretty much anything with indices. There are a couple of ways that we can do it. The first one is we can check if all of them are different so far. Sorry, if the new value that we have to input is different from the ones that we already have. Right, but that's another for loop, which is gonna make things a bit more complicated. But what we can do instead is have for each digit, so for each number from 1, 2, 3, and so on up till n, the number of places that we have, we can keep track of whether this one is used or not. So this one is, let's say that this one is used, this one is not, this one is used, this one is not. We can just do another array which is going to keep track of that, and we are going to it's going to be Boolean, and we can just keep track of which one is used and which one is not. But again, it's very, very similar to the previous two things that we've done. So permutations. Okay, so what we need here is going to be just n, right, n equals, after that we have int num equals int.parse console.readline, and we will need also an array. So that's going to be int array equals new int of num, and bool used equals new bool of num. Okay, and here we'll just keep track of which digit is used and which one is not. All right, and after that we'll just call calc permutations. And what do you think should be in here? I said that everything that we need to keep track of should be inside the method as a parameter. So what do you think should be here? Or let me just write the method first. So private static void calc permutations. Okay, so what do you think should be in here? What do we need to keep track of? Index, so int index, the array. Okay, so int array, and then the other array, right? Bool used. That thing shouldn't be there. Okay, what's gonna be the bottom? It's the same, right? I'm not gonna keep asking that. So index equals array.length. That is fine. And then we need to print it. So console write line string.join separator and array. All right, and now comes the same step that we need to do, right? So for we're always going to start from 0, so we want to always you know, you can do it with start and end and so on, but we just want to make it simple here. So we're always going to start with, you know, we'll just generate 0, 1, 2, 0, 2, 1, and so on. It's the same. I can also make it so that we start with a 1. We can do that as well. From 0 to array.length. And after that we want to do if alright, let's not do that now. So it's the same thing, right? Array of index equals I, and calc permutations. Okay, so the index is going to be index plus 1, and then we'll have array and used. Okay, so how do we incorporate now? Actually here, let me just put in 0, array and used. How do we incorporate now this array used here? So how can we keep track of which numbers have we used and which ones we haven't used? Yes, no? Okay, so how do I say I've used, so I filled in here the 0 at the current step. How do I say, well, the 0th element is now used? Used of index, sorry, of I in this case, because you know we filled in the 0 equals true. Okay. Okay, so but this way this is true, but I have to do something else, because after going through all of the values once, so as soon as I have 1, 2, 3, 4, or you know 0, 1, 2, 3, all of these are going to be used, right? So I'll be able to only do that once. So I have to somehow reset this value somewhere to false. And where should that be? After this method, right? So here I should just reset it and say used of I equals false. So once I start going back, then I've freed up this number and it can be used once again. Okay, and all of this will happen only if the current cell, you know, is not used. So I should do that. Control KS, I think, if surrounds it with an if. I learned that recently, by the way. So if not used of I. So if we can use the current value, or if the current value is not used, then we can do this whole step. So if we have a free number to put in for the next number, then we do it. So control 5. If I put in a 5, 5 is too much again. So if I put in a 3, we get all of these here. So 0, 1, 2, 0, 2, 1, 1, 0, 2, 1, 2, 0, 2, 1, 2, 0, 1, and 2, 1, 0. and we get all of them, and we get them in order, right? You can easily change that from a 0 to 1, but you would have to do some changes to the array as well. But I'll leave that as a homework. So if I want to start with 1 and go until the length of the array, what do you think is going to be the problem here, or is there going to be one? I'm going to get an error. Okay, and this error is because I am trying to change the value and actually put in I am trying to change the value of this used of I, which goes outside of the bounds of the array. So in this case I would do this +1, just make a bigger array, and that now should work, right? Because we changed used of I, and now I is from 1 to array.length included. So at some point we are going to try to access something that is not there, and there we go, from 1 to 4 in the same order that you would see it normally. Yes. Can we just change used of I -1? Yes, of course. So let me put that here, and we can say used of I -1. We can do that. Sorry, I have to change it everywhere. So used of I -1, used of I -1. 4. Yeah, we can do that as well. But I was lazy and I wanted to change just one value. So yeah, here I had to change all of them. Okay, is that clear how it works? So you can fiddle around with the values, with the start, with an end, and normally you start with something simple. So first we would start with the bottom, or at least I will, because that's the easiest thing to see. So when does it end? And if you get that kind of thinking where, okay, so I should always start with the bottom, you will never get the error which says that you cannot do that anymore. You get into an infinite loop. All right. So finally, so I hope you got the hang of the combinatorial algorithms. They're not that hard, and they're always like something along those lines. So if you ever need to do something, you can always have a look at that. If you have to implement something new with recursion, it may take you a while, but I'm sure that if you think of it logically, step by step, see what the bottom is, see what the step is. So you should always put yourselves, okay, so I am somewhere in the array or the matrix or whatever problem you have. So I am at one step here. I don't care what's before that. I just need to figure out how to go from this step to the next one. And that's the only thing that you need to look at. The rest is done by the recursion itself. All right, so finally, we'll do something which is not combinatorial, or at least not in that sense. So we will try to find a path in a labyrinth, or where the exit is. So in this case we have a bunny, of course, and it needs to get to the carrot, which is down here. And first of all, can you tell me how many ways are there to do that? Imagining that these are not allowed. How many ways are there? 3. So 1 through here. The next one, let me put that with green. The next one is straight to here, and the final one is from here. Okay, and this is done with recursion, and it's very, very simple. So if you have to do this with some sort of, iterative way, then I don't know even if you can do that, because you have to go through, all possible paths, and try to figure out when to go back, when to keep turning, and so on. So in this case there are a couple of problems that you can see. So the first one is, what's gonna happen if I am here? right? I have to know that there is no way out, and I have to, go back somehow. When I say go back, you should always assume something like a bottom of the recursion or some kind of an exit from the method that we are currently in. Okay, so let's approach this slowly and do the same thing that like do the steps that I just said. So the first thing, that's probably the easiest, I think. Okay, so when do we exit, or when is the bottom of the recursion in this case? So let's say that we are going around, and we want to know when we really can't go any further. So when should we start backtracking? So yeah, when we reach the carrot. Okay, so reaching carrot. After that,
If there is a trap.
okay, so if trap, and one more, which is actually quite important.
If there is nowhere to go.
If there is nowhere to go, can you define that a little bit more?
Because you can go back.
Because you can go. Sorry, are you talking about this case where I go back here? Okay, so when there is. So the first one, what was it? Carrot. The second one was trap. The third one is no. I don't know, no way to continue. And the fourth one, which is also quite important. Sorry?
If we run into our track,
In,
where we were before.
if we run into our, yes, so yeah, this is no way to continue. So yeah, this is this case where we go and do this way, and now we know that we have to backtrack as well. One more. World bounce. World bounce. Or in this case, think of it this way. So I am, let's say, here. This is not a good spot. Okay, I am here. Alright, I am coming from left. So this one I cannot go back to. I have to check this one, this one, this one, and this one, but we know that we can't go there. So this one we cannot go in because it's a trap. We can go right, but at some point we'll also be checking the possibility of going up, and we cannot do that because we are just outside of the array, and we'll get an error and so on. So these are the four things that we have to check as an exit. All right, now, and I've said it now, but the second thing is to actually think what the recursion should do. We already have the exit, but what should it do? Let's think of it this way. What's the strategy? So let's put ourselves in a random spot that we have that we've gone to. So let's say that it's this thing here. Okay, the previous step is here, so I don't care what's been happening here, whether the bunny was going this way or this way. We just don't care about any of that. Okay, we know that we are here. We have come from this place, and now how would you approach solving the problem? How would you, like, if you were in this spot, how would you choose your place to go to next? Okay, so check up, check right, check bottom, and that's it. And if you can move, meaning up, we can't move, right, we can, so we call it once again. All right, so let's implement that. It doesn't sound that hard, right? So here I have an array which represents the same labyrinth that I have here. But first I would like to create my final solution of the day. Project. This is gonna be 6 labyrinth, and so if I put this here, maybe you will be able to see that it's the same. So we have the start, which is at the top left, and then we have traps here and here. Actually, I'll just write. So we have two traps, which are here. We have one more here. We have a whole block here, and so on. So it's the same. I've checked. And our exit is here, marked with an E. So we have space for where we can go to. We have a star where we can't go to, or there are traps. And then we have the exit, which is here. And okay, so a couple of things that we'll need. So I would like to do this with another class, so that I can do some things a bit later on. So here we would like to say var lab equals new labyrinth. That is weird. New labyrinth of matrix, and we just want to say, well, lab dot find exit starting from 0 0. Okay, so let's create that. This is going to be a class. So I don't think that should be where I put it, so more like here. Public class labyrinth, and each labyrinth should have, you know, some kind of a matrix or an array that we have to check. So this is going to be private char matrix, and we can have a constructor for that thing. Control dot. That's not what I wanted to do. Why are you not working? So home control dot constructor. There we go. And after that, we just want to have the method, which is going to be find exit. So public void find exit, and think about what is it that we need to keep track of at each step. And I've already helped you with this call here, but what do you think is it that we should keep track of? Okay, so row and column, right? So int row, int column. Okay, so let's start with the bottom. What did we say? So caret, caret bottom. We also said trap bottom, visited bottom, and outside of array bottom. Okay, which ones do you want to do first? Sorry? Caret. Okay, so if this dot matrix of row column equals what? E, because it's, you know, it's exit. I can also call it C for caret. That's fine as well. Okay, so when that is true, we would like to print solution, which I can do now. It's going to be quite simple. We can say for this dot matrix, if you don't remember, dot get length of 0, and I want to have another for loop here, j this dot matrix dot get length of 1. So these are the number of rows and columns, and I just want to say console write just write, I think, here, and we want to do this dot matrix of I comma j, print a new line after this one, and if we have multiple solutions, we would like to also print something like a separator. Maybe something like this. Okay, and oh, I think here it would look better if we just do that kind of separator, but we'll see. Okay, so we are fine, and of course we have to return, right, after we've printed it. Okay, trap. If, what should I put in here? The same, but with a star. Okay, so this dot matrix row column equals we have a star. What should I do? Just return, just go back. Visit it we'll do in a bit, but then we have to do the outside of the array. So this is going to be if row less than 0 or row bigger than or equal to this dot matrix dot get length of 0. So those are the number of rows, and then we have call less than 0 or call bigger than or equal to this dot matrix dot get length of 1. Okay, so that's yeah, question. Shouldn't this one be at the top? Yeah, sure, of course. I can check that because oh yeah, so yeah, you are right, because we would be checking here some things with row and call, and if we if we actually let through up to this line, negative values, we will have a problem. So yeah, let me just finish it and I'll put it at the top. Okay, so here we just need to return as well. Let me now get that, put it at the top. Actually, let me do that again. Control X. Okay, and this one we'll do in a bit. Alright, so what is it that we should do now? So let's say that we found the new place. Sorry? We should keep track of the cells that we visited. So how would you do that? An array. Can we just use the one that we have? We can change this space to something else. So this dot matrix of row and column equals let's say V. Okay, and what is it? Of course, we have to reset at some point. It's very similar to what we did with the previous problem here. So after we've called all of the methods, actually let me change that. I did not change that earlier. Okay, so after we've done all of the work here, we would like to also reset it to its original thing. So it's like, okay, we have found either a way or some place that we can't go to. Actually, let me just show it here. So we are going here. Okay, now we start returning or going back. So going back, I should keep track that this one is no longer visited. So I should just unmark that, which is just this with the space. Sorry, is this not gonna? No, because we check different. We check different directions this way. We don't just check one. There is no way. So once we've checked top, let me just get back here. So once we've gone here, imagine that we were at this step. Okay, so we've checked left, we can't go there. We've checked top, we went there. Now when we go back, because there is nothing here, then the next one that we'll check is right. Okay, this is not, and then we go back. Okay, so we just check them in order. Alright, so what should I be doing here? So now this is actually where we go around the labyrinth recursively. What should I do? What would you do in each step if you were in that cell? Sorry? Okay, so call the method. So find exit of what? Row plus one call. This is gonna be down, right? Find exit. What is the next one gonna be? Row minus one call. This one is gonna be up. Find exit. Roll call plus one. This is gonna be right. Yeah. Find exit. Row call minus one. This is gonna be left. And I guess that's it. So if we could go diagonally, how would you do that? Yeah, row plus one and call plus one and all of the combinations that go from there. Okay, is there anything else that we need to do? I think not. So, yeah, this one, visit it. Okay, so now that we have that with a V, we have it. We have a visited cell. Then it's pretty much the same. So if this dot matrix of roll call equals V, then we just return. Okay, and to be honest, I could have combined at least these two. Okay, or I could have put them here as well, and that was going to work as well. But you know, this way we know which one is for what. Okay, so let's try and run this and let's see if we have. So remember that we have three ways. So we have this way, and this way. So we should expect to get all of these three here. Okay, so this is the first one, this is the second one, and this is the third one. Okay. And you see that the code is pretty much again 5 lines. It's nothing that weird. So these are just some checks that we need to do, but the most important thing is here. And now we can, you know, find the exits in a labyrinth. Okay, so a couple of things that I want to discuss, which are in your homework. Let's say that you have to give the bunny directions. So instead of giving it this way with a matrix, we would like to give it in terms of, you know, go down, then go down, then go up, you know, left, right, and so on. How would you do that? That's in your homework. You know, it's the same, but you know, after every solution here, you should also give some sort of directions to the bunny. How would you implement that? So string builder, yeah, that is fine. But what's your idea? Let's say that it's a string to make things easy. So you have a string. Okay, so you add which way you were going to be going. So it's either down, up, right, or left, and you can just use the first letters. And you do what? And you push them into the array once you decide to use this method. Okay, so it's that. Okay. And I guess that's that for today. Let's go through the notes here that I have. So recursion is normally slower, but not always, than if you were to write it with a for loop or while loops and so on. In most cases, you can do an iterative solution to a problem that is done with recursion. So I think you can do something for the labyrinth searches as well, but that will be really complicated and hard to read. Normally it involves while loops and so on. It's never easy. Whereas with recursion, it's easy to read and also to implement, because it's just five lines of code, or just a couple, and everything is done for you, almost like automatically. You just do one step, right? This is what we normally do. We just do one step, and then everything else is done, out of nowhere, which to me is, kind of weird at first. Okay, and some problems cannot be solved otherwise. Okay, there are really some things that really are not possible to be done any other way. One thing that I didn't discuss with you, let's say that I asked you to generate permutations, but without using recursion. So how would you do that? Let's say that we have three elements, three elements, 1, 2 and 3, and we have 3 boxes. How would you print all of those on the console? And let's say that they're with repetitions to make that even easier. Okay, so for loops. Okay, so 4 from 0 to 3, 4 from let's start from 1. Okay, from 1 to 3, then from 1 to 3, from 1 to 3, right? And then you just print those, and it's fine. Okay, so why not use that, right? That seems simpler than using some kind of recursion and calls and so on. The problem is that if you want to do it for n, you would have to do n for loops. So there is no way to tell. I need to have, in this case, I need to have 4 for loops. In this case, I will have 5, and in this case, I'll have 10 for loops. This is not possible, and normally recursion is used when you have to have a non-fixed number of for loops. So if in one case you need 2, in another case you need 3, 4, 5, then normally recursion is the way, and there is no way to do that. Or there is, but it's going to be really hard to do it with iterations. I think there are algorithms, but they use while. And in here you wouldn't want to read what's happening here to generate something like this, which is normally done very, very easily with recursion. Okay, so this is your homework. It's if you got anything out of this lecture, it will take you no more than 30 minutes. Most of the problems are already written for you. So find the nth Fibonacci number with recursion. So that's simply t of n equals t of n minus 1 plus t of n minus 2. Oh, come on. Plus t of n minus 3. Okay, so simple, I think. After that, you have to generate all permutations and combinations of these sets, both with and without repetition. So we have a set of some strings that you have. It's not numbers now. You don't have a start and an end. You have to come up with a way, instead of the numbers, to put in some strings or some objects, and so on. But in this case, I've just given you strings because I think that's enough for this problem. Solutions are within the demos, and we've discussed most of them. And then finally, you have to find an algorithm which calculates the shortest path. So it's going to be just one. But you can move up, down, left, and right. Also the diagonals, and you have to give it both with a table, the solution, and also the thing that we discussed 2 minutes ago with the directions. Is it clear what you have to do? It's relatively simple, I think. So in this code here, how would I calculate the shortest path? Okay, we can count the number of v's. We can also just, instead of putting a v, we can also put numbers depending on which step are we in. So something like this is 1, 2, 3, 4, 5, and then finally we will get some number, and we'll look for the smallest one of these. You can also do it with a simple counter. It's up to you. But yeah, I guess that's pretty much it. So references, and if you have any questions, let me know. So next lecture is about dynamic programming, which is, so now we've learned how to deal with recursion. In the next lecture, we'll learn how to avoid it, or when it's a good idea to come up with some smarter solution that is not gonna take that many steps. But we'll see about that on Thursday.